Tonight we are going to look at area, average, and ratio. And I'd like you to start with the average and ratio because we're just going to buzz through those quick. You guys have seen these before, and we actually just did ratio problems, so you should be fine with those. I'm just going to go through the average ones with you. And then we'll go on to area because they're a little harder. All right? So basically to work out these average problems, you need to set up how you think about averages. Well, averages, remember, are the sum of what you're taking divided by the number of what you're doing. So if I'm averaging, speeds of something, I would add up all the race times and I would divide it by the number of races, and that would give me an average. So Woodstock has grades of 75, 82, and 90. What must he receive on his next test to have an 85 average? So I'm basically saying I need 75 plus 82 plus 90 plus some number divided by, I need 4 tests to get an 85. And then you just, you can put this over 1, cross multiply, simplify, and in this case, if you do the math there, you should get 93%. So I think that you're probably in good shape to do those on your own. 3 is a little bit different, but remember that you need some number of 100s. How many 100s does he need? Let x equal the number of 100s. Okay? And he has a 70, a 50, and a 60, and an 80, and he needs some number of 100s to get an 86. Well, how many things did I add up? I don't know. I added 4 tests plus that number of things. And then you would need to solve that equation. All right? The ratio word problems, I'd like to just see what you can do on your own there because we've done this. So this was in our percents unit, and you should be able to get through those okay. I'd like to focus our time instead on area word problems, and so you should be on this page. They're going to look a little scary at first, but I think you'll find that you can get through that with a little bit of perseverance, okay? So the length of a rectangle is 3 meters more than its width. So I'm going to draw a little rectangle here. This isn't a lot of space, so a lot of you might want extra paper for this section. The length of the side of a square is equal to the width. So I have a square also that's x by x. The area of the rectangle exceeds the area of the square by 15 meters squared. Find the dimensions of the rectangle. Well, what is the area of the rectangle? It's x times the quantity x plus 3. So the area of the rectangle is x squared plus 3x. What is the area of the square? X squared. So we know that the area of the square, the area of the rectangle exceeds the area of the square by 15. All right? So the area of the rectangle is more than the area of the square. So to set them equal, the area of the rectangle is the area of the square plus 15, right? So x squared plus 3x equals x squared plus 15. You're going to say, no, we don't know how to solve quadratic equations. Well, they're going to drop out in most cases for you. There might be one where it doesn't, but it would be a situation where you might get like x squared equals 25. All right, and you should be able to solve that. So, taking a look at this one again, I would solve that, subtract x squared from both sides, and it cancels out, and I get x equals 5. So then I go back and I say, what do I want? I want the dimensions of the rectangle, so that's going to be 5 meters by 8 meters. Good? So as you can see, they look a little scary to start with, but I think you'll be okay with them. All right. So maybe let's do number 2. Why not? All right. The length of a rectangle is 4 more than the width. All right. So the length is 4 more than the width. If the length is decreased by 2 and the width remains the same. So the length is decreased by 2. So now it's x plus 2. The width remains the same. A new rectangle is formed whose area is 6 less than the area of the original. So the area of the original, write an expression for that, The area of the original is x squared plus 4x. The area of the new is x squared plus 2x. All right, and the area of, back to this here, area is 6 less than the original. Okay, so the new one has an area that's 6 less. So the area of the old equals the area of the new, or the area of the new, sorry. Right, the new one is 6 less. So the area of the new is the area of the old minus 6. So that means that x squared plus 2x equals x squared plus 4x minus 6. And then if you solve that, solve, you get x equals 3. And then I got to go back and figure out what they want, the dimensions of the original. So the dimensions of the original are 3 units, by 7 units. And again, if you're checking these, you want to just check the area. So 3 by 7 is 21, and then this is going to be 3 by 5, which is 15, and that is 6 less. So it checks. All right, that's how you would check them. So I would like you to do the rest of those, and I would say that be careful with number 5, but you can do it. I'm going to let you go with it. And it looks like the rest of it should be fine. So finish up those average ones. There's 2 there, a couple ratio problems, a few ratio problems, and 3 area problems. And we'll regroup together tomorrow. Have a wonderful evening. Okay, so I figured I would go through the solutions to the leftover area problems just so you know whether or not you're kind of getting it. And we'll start with number 3. So for number 3, basically what I did here is I said that I had an original square with a side length of x. And to get a new rectangle, I have the same width, but I decrease my length by 2. So it's actually not drawn to scale, shall we say. All right, so the area of the original square is x squared. The area of the rectangle is x squared minus 2x. And I know that the area of the rectangle is, the rectangle is formed whose area is 26 inches less than the area of the square. So I know that the area of the rectangle is 26 less than the area of the square. So I just set my equation of the area of the rectangle here, 26 less than the area of the square, and I solve it and I get x equals 13. Now it does ask me to find the perimeter of the rectangle. So since this is an 11 by 13 rectangle, it's going to be 24 times 2, or 48 inches equals the perimeter. Okay, perimeter equals, there we go. Alrighty. Let's look at number 4. Now the next 2 you have to do a little fancy footwork, I'm afraid. Alrighty, so the first thing we do is we set up our rectangles, and the length of a rectangle is 4 more than twice. Don't miss that twice there, it's kind of sneaky. Okay, and if the length is increased by 5, so that's going to be 2x plus 9 for the new one. This is my original and this is my new. Okay, the original is 2x plus 9 for a length, and the width is decreased by 4, so x minus 4. The area is 51 less than the original, so I write my expressions for the area. Now in the case of the new rectangle, you have to multiply a binomial by a binomial. So you need to be careful with that. Simplified, this is the expression you should get. And I know that the area of the new is the original less 51, okay? So I can set those 2 expressions equal, and I should get x equal to 5. I have to find the perimeter of both, so I think it is maybe 38 and 40. I'm not totally positive about that, actually. I have it penciled in there, but I think that's what it is. All right, so the length of a rectangle is 3 feet more than blah, 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 blah. So I draw my pictures, 3 feet more than twice again. We have that little twice here, so that's how I get this length. And then the length is decreased by 5, so I have to subtract 5 from 2x plus 3, which gives me 2x minus 2, and the width is increased by 7. So I write an expression for both of those areas, and again, here it's a binomial times a binomial, so you have to simplify it out to get this expression. And I know that the resulting rectangle has an area 30 feet less than 4 times the original. So I don't know where I got 51 from. I must have been looking at the other problem, but this should be a 38. Okay, I think the answer is still right, but I think I just wrote it in there quickly. And so I have to take 4 times this whole thing. Keep in mind when I put that in there. All right, so the area of the new, which is this simplified expression from the binomial multiplication, equals 4 times 2x squared plus 3x, which gives me the 8x squared plus 12x minus 38. And then I get x squared equals 4 and x equals 2. But the question asks me, how many times bigger? So I have to find both of the areas. The area of the old, this is therefore, remember, I think I've told you that. The area of the original was 14 units squared. The new was 18 units squared. And 18 divided by 14 is 1.2857, which is approximately 1.3 times. So hopefully you understand those now. We will have more practice tomorrow. Enjoy your evening.